Hello everyone, and welcome back to Hacktivity Explained, the series where I go over some bugs found by other hackers in the hopes that you might learn something from them. And in this video, I'm going to be covering two server-side request forgery vulnerabilities. One on Shopify and then one on Google. And both of them are kind of metadata leaks vulnerabilities. If you don't know what server-side request forgery is, then I made a whole video about it last week. So I really recommend you to go watch that as I go into a lot of detail and show a lot of demo examples in it. But without further ado, we'll just get into the video now, starting with the Shopify app here. Right, so this vulnerability is a kind of redirection type vulnerability. So basically, in Shopify, you can make a store and you can code a bit of JavaScript into it. You can edit the templates and you can add whatever scripts you want. That obviously is going to open a whole lot of vulnerabilities. Well, in this case, it's going to allow us to do server-side request forgery. So what the hacker did here is he created a script here, which just sets the location header to the Google Cloud metadata. So the metadata here is going to give us the credentials to be able to log into the server usually, and basically perform actions on it. So this window.location, this what the script does is it basically redirects whatever user goes into it to the location that we want it to. In this case, the metadata. Metadata is behind the firewall, so a normal user won't be able to do it. But if the server makes a request to that, then if we see the response, we'll be able to read the metadata. Very good. So what the hacker did then is they created a store on a platform called Exchange. And then basically what Exchange does is it gets a screenshot of the page. So what happened here? Basically, Exchange went to take a screenshot of the page. Then, as it did so, it got redirected to the metadata and it took a screenshot of it. Because the Exchange platform is behind the firewall, it's the actual server, it was able to access this metadata here, right? And when I took the screenshot, it returned it to the hacker, and the hacker was able to read the metadata from it. And normally these metadata endpoints are kind of secured nowadays. So you need kind of headers to basically be able to find these metadata ones, basically to prevent server-side request forgery attacks like this. So you will need to include some kind of header like that. But the hacker found a way to basically bypass that by just attacking an old version. So basically attacking some kind of beta version of the metadata here. As you can see, and in Google you can basically every time in basically every Google API you can put this alt here, and you can just specify what format you want it to be the response to come into. Apparently text, but the responses weren't working, but JSON was working. That's kind of a common Google API thing that you can use. And this is where it kind of gets interesting, right? So we've got the metadata now, great. Now the hacker was trying to escalate it to an RCE here. And the way he did this actually is by attacking the Kubernetes cluster. So a Kubernetes cluster is kind of a management system for a number of containers, right? So if you imagine like a Docker container, it's kind of just like a separated piece of the memory. It's basically another partition that was created, and that's running the website. This is good because the websites are all kind of cornered off from each other, so you're not able to access other websites. Even if you manage to get like a remote code execution on one of the websites, you might not be able to basically escalate to the other ones. So what we want to do is we want to find a way to attack the Kubernetes cluster, so the thing that sits on top of it and manages the other containers, so that we can basically do whatever we want with all the containers inside. And in this case, that the Kubernetes cluster environment variable, which allows us to sign into the cluster, was also visible on the metadata. So in this case, the attacker was also able to basically find the certificate here, and then with access to the Kubernetes cluster, what you can then do is create new containers in the website. That means you can execute any command you want to. You can basically read existing containers, and then you can basically get secrets or like API keys from each of the containers as well. So that's basically how the hacker escalated the server-side request forgery to a remote code execution by first of all getting the metadata, allowing the attacker to log into the website, then kind of using that to get the Kubernetes cluster certificates, log into the Kubernetes cluster, and then creating new containers in order to basically execute code on the system. And this also allows you to see other containers running on the system as well. So all that is good. And the hacker was actually rewarded 25,000 for this vulnerability, which is insane. I mean, the amount of work was put in was probably matched the bounty here. I think this was a very complicated vulnerability to find. So in this case, I think the $25,000 for full remote code execution is justified, especially on Shopify. So this was marked as a critical. I don't know why it says medium here because it was marked as a critical, but yeah, that's basically our vulnerability here. What can we learn from this? Well, definitely can see here how redirections are very often used to find server-side request forgery, as we'll see in the next vulnerability as well, actually. So definitely finding a way to redirect the server is a great way to look for server-side request forgeries, and also in basically places that you wouldn't expect, like this. I think this is a mobile application actually. So trying to find server-side request forgery in unfamiliar places is a very good strategy like that. And yeah, I think that's basically it. Also, this is also a way just to bypass the headers. I don't think that this will work anymore. It was report 2018. Yeah, a lot of this has actually been patched at this point, so it's really hard to get this metadata, but if you can find a way to append headers, then you can, and you'll actually be able to access this metadata. Then you can also try and escalate this, as this hacker has done, by attacking stuff like Kubernetes clusters. And that's a very cool vulnerability. And now we'll move on to the one in Google, which was a Google acquisition, and it's also a server-side request forgery. Right. So our next vulnerability here is in Google AppSheet. So as far as I know, AppSheet is kind of like a database management tool, and it supports a feature called webhooks. So webhooks are basically like kind of bots that will send out a request whenever an action happens. So if we have our webhook here, right, what the webhook is going to listen for is for the server to perform some kind of action here, right? When it does that, the server is going to send a request to a domain that we specify. So it's usually going to be our website, and then it's probably going to log the response. So the reason that these webhooks exist is for companies to be able to integrate this kind of system like AppSheet with their own servers, right? That's going to allow them to keep track of what changes are being made. Maybe they want to have some kind of proprietary software or some kind of their own UI. They can do that with webhooks. So that's kind of the main purpose of them. You can see that this is probably the best, most tested feature for server-side request forgery, because by definition is going to be the server sending a request. At the same time, it's also the most obvious one for developers, which is why sometimes it can be hard to find server-side request forgery on this, particularly in well-tested programs. So it's good and it's bad at the same time, if you know what I mean. In this case, instead of pointing the server directly at the metadata, the hacker basically pointed the server to his domain and then redirected it on the website using the previously mentioned location header. So, see, the way this attack worked was that the webhook was here, right? And the webhook was going to the attacker server here. The attacker server was basically pointing it back to the same server, right? And telling it to fetch the response from the local host. And if you've watched my server-side request forgery video, if you can get the server to make a request to its own like local host, you'll be able to access those internal services and metadata. So that's basically what's used here, and it's just a 301 request here that's going to work for us. As well as that, one of the things that the attacker mentions here is that if you have a post request and you redirect the post request, it'll normally turn into a GET request. I think this also works with stuff like put and delete as well as that. So if you have these kind of requests, they'll actually turn into a GET request if you redirect it with your own website. You can use something called like webhook test. I think there's a website called like that, or like bceptor I think I used to use for this, and that kind of helps you test for these kind of type of vulnerabilities. So this server I think was using AWS metadata, or maybe it was not. Sorry, it was using Google metadata. Yes, so it was using Google metadata as well. And basically, when you trigger the webhook and you have this redirection pointing to the local host or the metadata, then you'll be able to access the metadata like so. I think this is an older vulnerability because today you would actually have the headers in. You wouldn't be able to just do it like this. But this is one way that you can verify that your server-side request forgery works. If this didn't work, let's say, then what I would probably do is try and look for some kind of internal services and basically point the server at like localhost and try and find something there. So the website fixed this by basically making sure that this header had to be appended to access the metadata. I think this is kind of not a great fix to be honest, but yeah, that's basically what they did. They've made the metadata have this header, which still I think exposed the APIs and stuff like that behind it. Maybe they didn't care about that, who knows. So in order to bypass this fix, the hacker actually tried to append this header at first, because you could actually set out a webhook as well. I think they're probably using some kind of regex or something to filter out this header here. But when you do this, you're going to often, this is not really a great fix because there's a lot of kind of documentation inconsistencies that can pull up with stuff like this. This header is, sometimes you can find replacements for it. In this case, the hacker did exactly that. They found a header which was the exact same thing, but that wasn't filtered out by the patch they put in place. In this case, they were once again able to access the metadata, and this time they were able to append the header. Now, this is quite rare, to be honest, being able to send the header with the request as well. If you're able to do that, well, then you probably found some kind of gold mine here. But basically, most of the time you will not be able to append this header, and most of the time the metadata will be secured. So you might have to look for other ways to bypass it, like we saw in the previous example here. So for basically attacking the original server-side request forgery and then the fix, the hacker got a combined total of about let's say $6,200. If you're European, that's probably about €6,000. So a decent payout from Google. Definitely less than the Shopify one, which is interesting, but I think this is because this is actually a Google acquisition and not Google itself, so they pay a little bit less for recent acquisitions. Well, this was implemented in December 2021, so not that long ago. Maybe it's worth looking at something like this. Yeah, these webhook features are always going to be decently good to test for server-side request forgery, but to expect the developers to be aware of this as well. They're not going to do some not just going to allow you to point to the metadata. You might have to find some kind of bypasses for it, and you might have to kind of look for redirections. Another thing you can try and do is DNS rebinding, maybe. You could definitely try that as well. I think that's a cool technique as well. I actually have a lab detail with that. So I have bug bounty labs in the description, and I have a couple of server-side request forgery vulnerabilities like this one. And if you want to learn techniques like DNS rebinding, I have labs made for them. Go to learn the theory. I'm talking about the theory right now to you, but definitely bug bounty is very practical. So if you want to basically find vulnerabilities, you have to learn how to do it yourself, enumerate stuff, exfiltrate data with server-side request forgery. So that's why I created labs, because I think that they're very useful. And yeah, do check them out in the description. But yeah, those are the two vulnerabilities we covered today, two server-side request forgeries, and I do hope you enjoyed this video. If you did, the previous episode is on SQL injection. I think those two vulnerabilities are actually really cool as well. And I think a previous Hacktivity explained video was a vulnerability of how someone hacked a page with a 404 request. I think that's probably the best explanation I've had so far for a vulnerability. So do go check those two videos out. And anyways, I'd like to thank you for watching and happy hunting.